Thank you so much. I appreciate all the background information there. And hello, everyone. I want to welcome you to Addressing Project Change Without Pain. Thank you for attending this webinar. Throughout the session, I'm going to present diagrams and models from my 2 books that I mentioned before that can be used on any project throughout the life cycle of the systems. So in particular, I'm going to focus on a set of processes that are complementary between the project management and the systems engineering disciplines. If you are unfamiliar with either of the disciplines, that's not going to be a significant hindrance to understanding the methods that will be presented here. So I hope you find the materials that are presented to be helpful to you. And so during this webinar, I will present this integrated approach to life cycle management of a system. And then we're going to explore the topic of project volatility, or the level of expected change within the project throughout its life cycle. We're also going to review techniques used to establish trajectories and baselines, which will be used to measure change. And then a discussion of the measurements that can be applied is discussed after that. Governance activities are those activities which are used to manage change effectively, and we're going to review the most common activities that can effectively manage change. And then finally in this session, strategies that will help ensure successful change management during the execution of the project will be discussed. So let's start now with a focus on the project life cycle. A life cycle is an end-to-end look or systemic view of how an activity evolves over time. It can be used to facilitate decisions on when to invest in new technology that will either replace or rejuvenate that existing capability. And it has phases that provide structure and focus. So I have 2 diagrams here on the slide. The diagram on the left demonstrates a strategic plan and initiatives feeding into a portfolio of activities. And within that portfolio, this particular one, as it's described here, there's a program, a project, some strategic R&D activities. In this particular example, the program also has elements of a project to incrementally improve operations processes, and an upgrade project that's utilizing both traditional and agile project management, and some R&D inclusive of basic research and spiral development. So from this perspective, I'm demonstrating the life cycle as a cumulative view of all activities from the earliest research and development to a later phase operations upgrades. So the right side diagram provides a model to assess where a project might fall and the technical challenge and expected performance timeframes that would likely be affected. So for example, a project with significant technical challenges with an expected longer performance timeframe would likely include elements that departed from existing capability and were inclusive of research and development. Having a background on the structure surrounding the activity and a perspective on what is driving the initiatives and what outcomes are designed from the activity will help provide the context for project structure, which we're going to talk about later. So, so I want to point out emphatically that change is not something to be avoided in a project. It's a natural byproduct of evolution. So change is going to occur in any project and in every project that you do. What we want to talk about here is the objective to anticipate the level of change and to plan accordingly so that you can be adaptive and be methodical about it so that you're not surprised by change, but that you can plan for the change. The earlier in the life cycle phase that a project is in, the more change you're going to be able to, you're going to expect from that activity, and the more change should be accommodated. So rigor is, you're not going to want the same level of rigor in an earlier project that you would as that project proceeds through its life cycle. So now, the later in the life cycle, the less change should be anticipated or expected, but the change will occur. The question is, can you manage that change so that you can minimize the impact to cost and schedule, which is really going to be important because it takes more money and time later in the life cycle to resolve issues. So you want to resolve those issues as early as you can. So the next thing I want to show you is this continuum of a project life cycle. I've got 3 different models here. Regardless of where a project falls within its life cycle, an appropriately applied level of rigor and discipline really should be applied so that there is always a good sense of what is being done and how risks and stakeholders are being managed, as well as what the boundaries are in terms of schedule and budget. The only time that's not true is when you have unlimited funds and unlimited time, which, you know, if you have that, you're unique, I think, because most of us are bound by the amount of money that we have and the amount of time that we have to do our projects. So on this slide, I show 3 models that can assist you in determining the place of your project within its life cycle. So proper assessment of where a project falls as a whole, and then its component parts of that, is going to be really important. On the top left, we'll start in the top left model, the life cycle flows from basic research through to closure, so going from the bottom of that to the top. In the middle of the box is a progression from imagination, where one is trying to understand the realm of the possible in the basic research area, to art, where one is creating, to craft, where one is building, and then on through production, where the final product becomes operational and then eventually retired. So there's one way to look at the continuum of a project life cycle. If you look at the right box, the right top of the slide in that box, this model focuses on additional considerations to help determine how early or late in the research and development process the project falls. So the model looks at approach, techniques, theory, simulations, prototyping, testing, etc. And it gives you a continuum from early development to late development. So for example, when you see approach, early development might have a very undefined approach, where late development would have an established approach. Same with the theory. You could have an unclear theory or questions that you're trying to pose in early development, but by the time you're in late development, you should have a clear direction, or what we're going to call a trajectory, and I'll talk about that in a little bit. So you can walk through these if you're thinking about where does my project fit, and kind of get a better sense on where you are in the early to late development, research and development spectrum. On the bottom are different renditions of a life cycle where project falls in different categories within research and development, where you have the basic research, applied research, early development, and late development. And you can look at the levels of control that we're going to talk about shortly, which will be based on where your project falls within this continuum. So I want to just reiterate, you know, we're not looking at eliminating change, we're looking at embracing change in this. That byproduct of evolution is really apparent as you are working through from basic research all the way into production. So also I want you to keep in mind that a single project can have elements that fall into multiple categories. For example, you could have a production project which has a software R&D element, and that complicates the project and adds risk. And you may be managing these different elements of a project with different methodologies, project management methodologies. I am going to come back to that topic later in our presentation. But these types of situations require a careful assessment of change controls, because you want to ensure that the appropriate controls for change are actually applied to each of the elements and the type and where they are in their project life cycle. So the methodology that I teach is a combination of both generic project management lifecycle methods and generic systems engineering lifecycle methods. And using this method extends the traditional project management activities through operations, maintenance, and support from a systems perspective all the way through closure. So all along this life cycle, change is occurring, whether it be